What's up, guys? Andrew Steinmetz, QA/QC manager with Genco Inc., coming to you with my latest video. Today's video is going to be about motor calculations for the electrical exam. So this video will be split up into 3 parts. Today's video is going to be on steps 1 and 2, the following video on 3 and 4, and lastly, the video will be about 5 and 6. So stay tuned for those, and let's just jump right into it. Step 1, find the full load current. So this is the most important step. So if you understand how to find the answer in this step, then it will work for all the other steps. So you need this answer on step 1, and you'll use it for all the other steps. So you got to make sure you understand how to find the full load current. Of course, if available, you're going to use the FLC on the nameplate. But for testing purposes, they usually don't give you that nameplate, so you got to figure it out. But as long as you have the voltage and the horsepower, you can find the full load current. So we're going to use Article 430.248 for single phase motors, and we're going to use Article 430.250 for 3-phase motors. So Table 430.248, single phase motors. One crucial point I want you to know here is that any voltage between 110 to 120, you're going to use the line for 115, okay? And then anything for 220 to 240, you're going to use the 230 line to find your answer. And just remember that on 430.248. And then if we go to the next one, 430.250. For 3-phase, same thing here. So 110 to 120, you're going to use the 115. 220 to 240, you're going to use the 230. 440 to 480, you're going to use the 460. 550 to 600, you're going to use the 575. Pretty simple. Let's go ahead and try a question out. What is the FLC of a single phase, 5 horsepower, 220 volt motor? Okay, so we're going to use Article 430.248. So we're going to go right here. So it's a single phase. We go to 5 horsepower, and then we go over to 220 volts, which is going to be all the way over here. Because again, we're using the 230 volts. So for that one, the answer is going to be 28 amps, and that is the full load current. Right there, 28 amps. Pretty simple, right? So let's do another one. What is the full load current of a 10 horsepower, 208 volt, 3-phase motor? So we're going to go to 430.250, right? So it's a 208, it's a 3-phase, it's 10 horsepower. So we got 10 horsepower right there. And then we got a 208 right here. So we follow that over. What do we get? 30.8 amps. That's the answer, 30.8 amps. Next question. So I'm going to ask this question and let you guys find it. You can pause the video and look the answer up yourself. But here we go. So what is the full load current of a single phase, 3/4 horsepower, 110 volt motor? Go ahead and take your time to look up that answer. Pause the video. The answer, 13.8 amps. So let's go ahead and go to the next question. What is the full load current of a 3-phase, 40 horsepower, 440 volt motor? Go ahead and pause, look up the answer. $52 amps is the answer. Step 2, overload protection. Take the FLC step 1 and multiply by the percentage giving based on what is in the question. For minimum protection, we use 430.32A1. And for maximum protection, we use 430.32C for maximum protection. So what we're figuring out here is the maximum overload protection to protect the motor, right? So when the motor starts up, it has an inrush. And we want to make sure we're covering that so it doesn't trip. But we want to make sure it doesn't heat up too much because, heat is the worst thing for a motor. So we're figuring out the overload protection for the motor. We're protecting the motor with this. So go to Article 430.32A1. And what you're going to see here, go ahead and look at one, a separate overload device that is responsive to motor current. This device shall be selected to trip or shall be rated at no more than the following percentage of the motor nameplate full load current value rating. So again, if you have access to the nameplate, use that. But if not, let's go into this. So any motors with marked service factor of 1.15 or greater, you're going to times that by 125%. So for the exam, if any question is asking about the service factor and it's giving a number of 1.15 or greater, then you're going to multiply it by 125%. Also, motors marked with temperature rise of 40 degrees Celsius or less. So again, if you see that in the question or on the nameplate, then you're going to times that. If it's less than 40 degrees Celsius or 40 degrees Celsius exactly, you're going to times the full load current by 125%. All other motors are 115%. So if the question does not say anything about service factor, then you're going to want to go with the 115%, okay? Or anything lower than 1.15. So let's go ahead and try a practice question. What is the minimum overload protection for a 5 horsepower, 230 volt single phase motor? So we're going to take the full load current, times it by the correct percentage, and it's going to give us the overload size. So full load current is 28 times 1.15 because they did not give us a service factor. And then you get an overload protection of 32.2 amps. Let's try another one. What is the minimum overload protection for a 5 horsepower, 230 volt single phase motor with a service factor of 1.15? Now it has a multiplier of 1.25 because it's giving us a service factor, and that's right at the minimum of 1.15. So it's 28 times 1.25, that equals 35 amps. So for maximum protection, generally won't see this too much, but just for the sakes of the exam, I'll give these to you as well. So basically, where the sensing element setting or sizing the overload device selected in accordance with 430A1 and 430.32B1 is not sufficient to start the motor or to carry the load, higher size sensing elements or incremental settings or sizing shall be permitted to be used, provided the trip current of the overload device does not exceed the following percentage of motor nameplate full load current value. Motors marked with a service factor of 1.15 or greater times 140%. Motors marked with temperature rise 40 degrees Celsius or less, 140%. All other motors, 130%. So you're only going to use these when it is asking you. The question is asking you, what is the maximum protection? Right? So that's when you're going to use this chart, and you're going to use it the same way we used the last chart to figure it out. But this is asking for maximum protection, not the minimum protection. So keys, you must say maximum to use the maximum percentage. So the question must say something about the maximum for you to use that. If it doesn't say it, use minimum percentages. If it doesn't mention the service factor or temperature, don't use them. Use the FLC on the motor nameplate if possible. So if it doesn't mention the service factor or temperature, don't use any of those, 1.25 or 1.40. You just go with 1.15, 1.15 and 130. So I hope that helps. Stay tuned for videos 2 and 3, and we'll hopefully get you to pass this exam.